This is the video to help you do the lab called Intro to Forces. The first part of the lab sheet you will do on your own, and then you want to keep that lab sheet handy, either print it out or have it on screen while you watch the video. And this video starts with problem number 4 on the lab handout. At that point, you have to watch the video as you answer the questions. So we start with this. This is a spring. This is for number 4. This is what the spring looks like. We call this normal length. And this is what it looks like when it's not applying a force to anything. It's not touching anything. It's touching my hand, but it's not applying a force to it. It's not touching anything at either end, and it's not applying a force to anything at either end, and that's its normal length. Now, what I want you to do here is just watch, look, see, but don't think. Don't try to reason things out. Don't try to use Newton's laws or anything you know about force and motion. Just look. Is this spring applying a force to my finger? So think about that. This is still number 4. Which direction is that force? But especially, how can you tell just by looking at the spring? How does the spring look different when it's applying a force from when it's not applying a force? And there's more than one way to describe how it looks different. This is how it looks when it's not applying a force. It is touching my finger, but it's not pulling it in any direction. And now it is pulling it to your left. How can you tell just by looking at the spring? I don't even have to tell you it's pulling to the left. How can you tell just by looking at the spring that it looks different? All right, the next one is number 5. This is for number 5. What if I compare this? Okay, the spring is pulling on my finger to your left with this. Okay, if I make the spring longer, what happens to the amount of force it applies to my finger? That's question number 5. All right? Now we'll look at question number 6 and the difference between stretching and compressing a spring. So, if I stretch a spring, what does it do? And then I have another spring that I can compress. So here's a spring. If I compress a spring, what does it do? Okay, that was number 6. Next is for number 7, so turn to number 7. And of course, at any time you should pause the video if you need to. For number 7, I'm going to attach a brick to a spring at the board. This is what the spring looks like normally when it's not applying a force to anything. And now here it is attached to a brick. This is for number 7. And I don't want you to think. I don't want you to reason it out. Well, if the spring weren't applying a force, then the brick would fall. That will give you the right answer in this case, but there will be more complicated problems, especially if you take more physics, where this might be in an elevator moving up or down, or the spring might be pulling upward on the brick and making it move up, or the brick might be moving down while the spring pulls up, or the brick might be going up and down. So we want a simple way to just look at a spring and tell whether or not it's applying a force and which direction that force would be. So that's number 7. How can you tell just by looking at the spring without thinking, what is it about the appearance of the spring that tells you it's applying a force, and which direction would that force point? And if you're not sure about this question, if you were here in person, I have you do this. If you're not sure, this spring's applying a force to this brick. If you're not sure of the direction of that force that the spring is applying to the brick, I ask you to imagine taking the brick away and putting your finger here. And ask you, okay, which direction is the spring pulling on your finger? And I think you can tell by looking at this, you can tell the answer to that question. All right, that was number 7. The next one that I have to demonstrate is number 10. For number 10, we move on to string instead of spring, right? And I put my left wrist in the loop of a string, and I go like this, okay? I'm pulling upward with my right hand on this string. How can you tell by looking at my wrist that the string is applying a force? Don't reason it out. Don't think, what looks different about my wrist when the string is applying a force? Okay, that was number 10. Next is for number 13. I'm going to hang a brick from a string, not a spring, a string this time. May be hard for you to see because the string is white. I'm going to hang a brick from a string. There we go. All right, yeah, you can kind of see that string. All right, and you can answer some questions about it. That's for number 13. Now we come to number 16. This is for number 16. I have this spring, and I like to use this spring because it's really easy to compress it. So we'll be talking in this part, in the support force section, only about compressing springs, not stretching them. So I have this string. This is for number 16, the beginning of the question, and I push on it like that. Okay, and I ask, do I feel a force, the spring exerting a force back on me? And the answer is yes. And if you look closely, you would see a dent in my finger. So that's the proof, that's the visible sign that this spring is applying a force on my finger. And you can ask yourself, what direction would that force point? Okay. For 16D, this is for 16D, we take a non-living object, this brick, and we set it on top of the spring. And I ask, can you tell? Does the spring look different? Can you tell whether or not the spring is applying a force to the brick, and if yes, in which direction? And I could put more brick on it like that, and the answer becomes even more obvious. All right. That was for number 18. Oh, I'm sorry, for 16D, I pushed down on it, so that's 16D. Sorry about that. And number 18 is the brick on it. There we go. And I don't want to reshoot the whole video, so I apologize. Okay. So 16D was I pushed down on it, and 18 is I set the bricks on it. All right, for number 20, I have a sponge. And this is all leading up to something. We saw that with the spring, when I push down on it, it pushes back, and that's upward. If I put bricks on the spring pushes back on the bricks, and that's upward. And now for number 20, I have a sponge. If I put a brick on the sponge, can you tell that the sponge is applying a force to the brick? Does the sponge look different now? How can you tell by looking at the sponge that it's applying a force to the brick? And for number 21, I put 2 bricks on it. Okay, so there's 1 brick and 2 bricks. There's a slight difference. You don't see a huge difference, but you should see a slight difference when I add a second brick. Okay, that was number 21. For number 24, this is what we've been building up to. Number 24, I have wood plank, just like a wooden table, and I put a brick on it. And this part of the lab's designed to get you to think about what this wood in the table does to this brick. I'll let you read it, think about it, and answer the questions, and we'll talk about it more in class. Right now, I'd just like you to figure it out on your own.